Next we will do a few examples. In this question, an open loop transfer function is given. Okay, so this is the open loop transfer function, and the question is to find out the type of the system. Okay, so this is a straightforward question. It is simply asking the type. What is the type? It is the number of poles of open loop transfer function at origin, right? So if you see the transfer function, you have a term s square. Okay, so it means that you have two poles at origin. Then what is the type? It is simply 2. Now the next question is, we have to find out the position and the velocity error coefficients for the transfer function given like this. Okay, so what is the position error constant? It is given by Kp. Okay, so this is limit s tends to 0 g of s. Okay, and what about the velocity error constant? It will be Kv is equal to limit s tends to 0 s into g of s. Okay, so here you can simply apply the limit for g of s. 50 by 1 plus 0.1 s plus into 1 plus 2s. Okay, so this you will get to be 50. S will become 0 and remaining will be 50. Okay, and next you have to find out the velocity error constant. This is equal to limit s tends to 0 50s divided by 1 plus 0.1 s 1 plus 2s. Okay, so this will be 0. Okay, because you have s in the numerator. And if you substitute that s equal to 0, the whole thing will become 0. Okay, so Kp is equal to 50 and Kv is equal to 0. Okay, so that is option C. In the next question, a block diagram is shown in the figure. Okay, it is a unity feedback closed loop control system. The steady state error in response of the system to a unit step input is what? Okay, so that is the question. It is given that the input is a unit step input. Okay, so it implies that u of s, right? U of s is the input, y of s is the output. So u of s is given to be 1 by s. Okay, and we have to find out the steady state error. Okay, so what is the expression for steady state error? This will be equal to limit s tends to 0 s into the input function, which is u of s, divided by 1 plus the forward path transfer function g of s. Okay, so this is for a unity feedback system. Okay, now from the block diagram we can get the forward path transfer function g of s is equal to, we have two blocks in cascade here. So what will be the equivalent transfer function? It will be the product of the individual transfer functions. So this will be 45, 3 into 15 is 45, divided by s plus 15 into s plus 1. Okay, so this is the forward path transfer function. So this we will get as limit s tends to 0 s into 1 by s divided by 1 plus 45 divided by s plus 15 into s plus 1. Okay, so this you will get to be 0.25. But in the options we have in terms of percentage. Okay, so in terms of percentage it will be 0.25 into 100, that is 25%. Okay, so answer is A.